Okay, so for our next update, we're going to get something completely different. This really fun project that has been worked on, a lot of work done by Junchao, Hong, Barry, Lois, who we wish could be here, but her daughter is graduating this weekend, and I guess she can prioritize that. Junchao is going to tell us about work on building AI systems to help developers and users. So, Junchao, thanks. Please take it away.
Okay, thank you. I hope this talk is fun, even though it's a little controversial. Okay. Okay. So the background of this project, the Lois, the first person. Lois, he's a PETSc developer. She joined PETSc even before Matt?
Before Satish.
Before Satish, yeah. She is a senior computational scientist at Argonne, and she was selected as a DOE Office SAS Distinguished Scientist Fellow in last year. She gave a wonderful presentation in February of this year, and you can look at his presentation online. And with his fellowship project, Next Generation Ecosystem for Scientific Computing, harness community software and AI for mission-driven team size. A group of people at Argonne, me, Hun, and Toby, Satish, and other folks from Argonne Leadership Computing Facility, and Barry. We work together to see how we can harness AI to improve the productivity of PETSc users and developers. So we came up with these 6 areas we think that AI can be helped. Actually, when I look at these areas, I found in each area there are a bunch of startups and bigger companies invested heavily in this area. For example, for user support and community engagement. This area I'm most interested in. We are thinking how to use AI assistance to better serve PETSc users. Currently, you can contact PETSc developers, ask questions through mailing list or Discord, or with PETSc GitLab issues. But on these venues, we do not have that 24/7 support. If we have a bot that can answer most of user questions, then you can have better support, right? Also, we can have we can use AI for paper literature review and these things, and code development. I used the Copilot before, and recently I use another tool called Cody. It can do code auto completion, and I find it's useful. It's not totally garbage. When I do open a Python code, I saw complete syntax. Before I have to Google or go to Python documentation to look at the menu. But with these AI tools, I just select this line and then select explain this to me. If this is a very complex regular expression, how to decode that can the AI assistant is very good at explaining the code. So in this sense, it improves my productivity. Also, you can use AI tool to generate tests and help debugging and various things. Even for documentation, I think that's a various idea. Let's say you ask ChatGPT about a PETSc question. ChatGPT returns you some response. The response is half correct, half wrong. Maybe that's because PETSc documentation is not clear on this API or on this usage. So we can ask the AI assistant to how to improve the PETSc menu. So that's our vision of PETSc AI assistants. But at this initial stage, we want to focus on PETSc AI user interface to see how we can enhance existing large language models for AI. So we will do ranking and re-ranking. This work is done by Hong and Barry. So Hong, you can take over to introduce the ranking and the re-ranking.
Okay, so as Junchao just mentioned, the reason we do this is we want to enhance large language models. Because in practice, people often see that a large language model gives you some response that doesn't make any sense. Partially because the large language model, when you train the large language models, it doesn't have the information that is critical to answer your question. So for example, if you answer a question about a PETSc, the answer usually embedded in our user manuals or even in the source code. But apparently, these data are not used for training ChatGPT or some other large language models. So this picture shows what we want to do. This is the big picture. So the first part, these are just like the front end. We want to essentially, we want to use our tool on Discord, the email, and the web, and even the command line and IDEs. So, and under the hood, we need to do some PETSc-specific processing. So this part is about how we collect the data and use the data to generate the RAG databases and even fine-tune the large language model. We haven't been there yet, but we have done RAG. We have built a RAG database. RAG databases, and these databases are very useful for provide additional information to LLM to help the LLM to provide a response that is relevant to your question. So this is a workflow for RAG. So, by the way, RAG means retrieval augmented generation. So first we collect some PETSc documents, and these documents are segmented into chunks, each of which is actually converted to a numerical vector representation. And these numerical vectors are stored in our document database for retrieval. And in the retrieval stage, whenever you have a question, so the user's question will be used to find the relevant embeddings from the document database. And then we can generate additional context to augment the prompt. So when you're talking about the large language models, you're providing not only the question, but some additional information which is relevant to your question. And you're asking the large language models to give a response that is more relevant to your question. So in our workflow, we added an additional step called re-ranking. So the first part is quite standard. So people do this a lot in practice for RAG. We build the database using the standard embedding model. And when we retrieve information, first we want the database to give us back top K relevant documents. So this part is based on similarity comparisons. And we added a re-rank step, essentially re-rank the question to passage pairs. We re-rank their relevance based on semantics. So the re-ranker runs actually much slower than the similarity-based retrieval, but it gives you more relevant information. So the first step is supposed to be really fast. The reason we want to use embedding is because it's much faster to compare numerical vectors than do the semantic based search. So from the top K relevant documents, the re-ranker will give you back top L relevant documents. So the order is decided by their relevance. So the first piece, the D3, is, for example, here, D3 is identified as the most relevant piece that you should use for the context. And we evaluated our model manually using 37 questions on the use of Krylov methods in PETSc. And they are ranked from score 0 to 4. So this plot shows how much improvement we made by using RAG. So you only need to look at the orange bars. So the orange bar, if the orange bar, so for example, this orange bar says 2, that means by using RAG, we improved the score by 2 points. So if it's a negative, that means RAG has a negative impact on the quality of the answer. So, but for most of the questions, you can see that the quality of the answers are improved significantly. But here's a concrete example. In this particular case, I'm asking the LLM, can I use a custom matrix format with KSP? If so, how do I implement it? So this is the LLM response. If you ask the question directly, for example, to ChatGPT, so the answer looks okay, but not perfect. But if we do RAG and ask the same question again, and you can compare so these are just part of the answers, because the answer return is very lengthy. So definitely I cannot show you the entire answer. So the left hand, sorry, I think there's something missing. Okay. So here you can see the major difference between these two answers. So the right part mentions about the math shell, but math shell is completely ignored in the answers on the left. So that's the reason how this typically this shows how RAG improves the quality of the answers significantly here.
I should maybe make a comment here. Before running the RAG and playing around with this stuff, I noticed that its answers with regard to Matt Shell were rather poor. And so I actually went in and improved the manual pages for Matt Shell. And the beautiful thing is then the RAG database then has this better knowledge and thus produces a better answer.
And do you know what the questions were that it did really poorly on?
Yeah, everything's in the repository. You can go look at it.
Oh, okay. Cool.
Yeah, so the score has been improved from 1 to 3.
Is the RAG database based on the PETSc dev mailing list and other things like that are semi-public, or is it just the documentation?
the RAG database including the mailing list, or is the RAG database just the documentation?
I asked Han that question earlier.
Yeah, so we have some concerns of using mailing list data. So for this particular study, we use only the user manual, but we can use the mailing list data as well. We have done that. But we cannot release any result at this point.
Can I ask you one brief question? When you're retrieving the top K answers by similarity, when search engines retrieve the top however many answers, 1,000 answers, they never take the just top 10 and return them. That's not what Google does. They actually take a sampling of the large number that they initially return. They do things like determinable point process or something to introduce variability in there, because it's important to get a wide sample rather than just return most relevant. Is there a similar statistical measure over the K that you use to get to L?
I would say this question is still an open question. So a lot of research has been done on this problem. So people have been coming up with a lot of new ideas on how, improving this.
Okay.
I would make one comment. My observations of looking at the answers and then feeding into the LLM is that if you put anything into your prompt that is really inappropriate for the question, generally the LLM kind of trusts that as being important and includes it in the response, even though it's garbage. So it's much better to just take a small number of things that are found and pass it in than a large number of things, because even one bad thing passed in can cause it to produce really bad answers.
It's really interesting because usually the strength of ML is ignoring the crap, right? That's why it's better than traditional optimization. So, yeah.
This may be true for the absolute latest and biggest models, but the models we were using last fall that you could run on one GPU and stuff, where they would really mistreat any information you gave them. So what I intended to do was try to have a system that pruned everything that was irrelevant from being passed.
Also, let me do a live demo of PETSc bots in Discord. Let me see that here. I will show our current workflow. So let me open the Microsoft. I use VS Code. So let me show first. I created a PETSc bot at Gmail. So then I use this Gmail account. I subscribed PETSc users public mailing list, and then I created a PETSc users label. So basically a directory. Then with Google Scripts. So with Google Scripts, I have write a JavaScript called with a function called alert Discord on new emails. So in this JavaScript, we will check new emails in PETSc users mailing list. If there are new emails under this label or directory, the script will run and then call a webhook. This webhook is for PETSc Discord So you can see this is the PETSc Discord. I have currently two private channels, PETSc users notification and PETSc user emails. So when there are new emails in PETSc users, the script will send a notification to this channel. And then I have bots in Discord to watch for notifications in this channel. Let me start the bot. Okay, I forget. I need to start the large language model. I use open llama. Oh, let me go llama. Open llama is a open source toolkit to manage various large models. So you can say I have llama, and let me copy the instructions from PETSc AI menu. So I export this llama service pod. Let me open that. Then start the llama service. Start service. Then run this llama 3.1 model. We can check through the llama utility. We can check the current model. So you can see the current model llama 3.1 notice is running. The size is 6.7 GB. Then let me go to PETSc AI directory, and I have chatbot and email bot. Let me start the chatbot. The chatbot will indirectly call email bot. So chatbot. Okay. Let's go back to PETSc Discord. You can see these two bots on now. Then we can in the PETSc bot email account. We have this script, and then I can set up a trigger to trigger this script. So I can the time driven event source. I can choose every minute timer, specify minute timer, every minute. Okay. Trigger the event. Let's see whether the notifications in this Discord channel. We can show that. Manually send a message in this channel. Okay. You can see this message triggered the email bot. So the email bot will fetch emails from the PETSc bot at the Gmail account and organize these emails in this channel, PETSc emails. And this fetched emails are organized in email thread. So you have, let's go back here. See here, you have this question about holding, there should be such. these new emails from PETSc users. And then let me open this. Fetch the emails and organize them in Discord. It's called a post. In a post, we have the title. It's the email subject, and then follow-up emails. Invoke the chatbot slash. Then I have a command from the chatbot. I will let the chatbot compose rapid reply. So chatbot is thinking. Let's wait. So the chatbot talks with the large language model I just studied. So this is a draft reply. Then all PETSc developers can see this reply, and they can look at this reply to say whether it's correct or wrong. It makes sense. Let's say I have two buttons. Looks good and send it, or totally wrong. Let's say it's totally wrong. Click. Delete. Let's do it again. Right? You are responsive.
Oh man.
I will send on your behalf.
Miguel won't talk to me anymore.
Check for the Norbert Weiner seal of approval.
That's right.
Norbert Weiner seal of approval. It's not the real Matt.
That's right.
So let's say Matt read the response.
Well, yeah. It's over-explaining. It's almost what we told him. It says, you want something that's not restricted to a cell, but restricted to just a subset. We should put it in, but we didn't put it in yet. So it's not terrible. Don't resend it to him.
So let's assume you think it's okay. Then you can just click. Looks good. Send it. Currently, I didn't send that to PETSc users. So you can say when you click the send button, it will log who approved this message. So
you're
solve.
responsible.
So then if you currently I just send it to the bot, to the PETSc bot email. You can see the email is here. So if I change the receiver address to PETSc user, then it will send it to PETSc users.
Okay.
So that's the current workflow. Of course, in the future, let's say you can still talk with the chat. You can add the chat, add the chatbot to say which part is wrong. Could you improve that? Then at the end, reach good response and then send out.
Oh, so you can give a prompt that says like this part's right, but this part's wrong.
Yes, you can. You can still continue the conversation. Also, PETSc users in the Discord channel can do direct message with the bot. For example, I have the chatbot. Okay, we have private message, do direct message. So you can think chatbot is
PETSc running
PETSc developer.
GPUs.
Okay. That's the current standards. We are thinking to fetch PETSc GitLab issues. Issues very like the emails. You have a conversation. You have two issues to maybe another Discord channel and to connect with the large language model. So, and at the end, we have questions for PETSc users. So this work, as I showed, is a preliminary exploration. Currently, we do not store. We do not do ranking on PETSc user emails. But whether it's okay, we want to hear your opinion. First, question for you is whether you want to use the PETSc chatbot in Discord if we think it's reach among is sort of useful.
All right, well, let's thank Junchao for showing us this cool new work that they've been doing. So this is a nice open-ended thing, which is good because right after this, we're kind of entering roundtable time. So yes, I'm going to go ahead. I'm going to stop recording on the presentations.
Swearing is back. No recording.